Welcome to topic number 12, foreign exchange. There is no underestimating the need to be able to convert an amount of money from one currency to another. Certainly, trade among the countries of Earth has skyrocketed in the last few decades or so. There are now many people who are making a living or even a fortune just by trading in currencies alone. I would not have considered this topic worthy of my slides unless I have seen an old past paper question requiring that candidates calculate a new rate of exchange after a currency devaluated against its counterpart. After giving the problem to my students, the responses were just as expected. Without much thought, they decreased the amount of money that is to be used to purchase the other. After handing the papers to them, I asked, if your currency was devaluated, would it take more or less to purchase the other? They gave the correct answer. Knowing my students, I did not think that they would have had the wrong interpretation of the problem. They did not interpret the problem at all. This has led me to make a formal presentation of the topic in which I have attempted to clarify what takes place during revaluation and devaluation. There is no great problem making calculations that involve a change from one currency to another. This does not mean that simple ones do not exist. US dollars can be traded in a free market at the rate of US $1 to Jamaican $64. At the foregoing rate of exchange, what is the amount received in US for Jamaican $40,000? And then, what is the amount received in Jamaican currency for US $562.50? Some students always get it right by just doing their simple multiplication and division. So they always get it right. So convert Jamaican $40,000 to US, they just divide, and they get $625. So the answer is US $625. And of course, they may just say convert $562.50 US to Jamaican. They just multiply by 64, they get $36,000. And that's all there is to it. So the answer is Jamaican $36,000. Most times, the only mistake made is dividing when one should multiply, or multiplying when dividing is the correct thing to do. This rut will be addressed in a short while. The form in which the following exchange rate will be written is somewhat less popular than the previous one. It is used in the opposite way. The reason will be explained by and by. A Canadian tourist exchanged Canadian $1,200 to Jamaican currency at a rate of Canadian $0.025, and that turns out to be 2.5 cents Canadian to Jamaican $1. She spent $28,000 and converted the remainder to Canadian at the same rate. What is the amount received? Convert Canadian $1,200 to Jamaican. Just do that. Divide, you get 48,000. So the answer is 48,000 Jamaican. She spent 28,000, so out of the 48,000, we are going to take 28,000, that is 20,000. We are going to take the 20,000 and convert that to Canadian at the same rate. So we are going to take the 20,000 and multiply by 0.025. And we are going to get $500. The answer is Canadian $500. When a rate of 0.025 should be used in order to get a large value, we need to divide by it. Dividing by fractions less than 1 causes the quotient to be larger than the dividend. The decision to multiply or divide may be made by considering the relative sizes of the figures used to define the exchange rate. The answer received after calculation should be related to the figure used to calculate in the same way that the numbers in the rate are related. We may use mathematical devices and physical structures to ensure that the relative sizes are maintained. Now, say you are dividing by 0.025. Any number you divide by 0.025, the answer is going to be larger than the original. Therefore, you are going to be saying, well, if I'm converting from Canadian to Jamaican dollars, I'm going to be required to get more money in Jamaican. The figure is going to be larger. So if you're going from Canadian to Jamaican, the figure is going to be larger. So you need to divide by a number like 0.025 in order to get a larger number. So in order to get a larger number, if you are going to be dividing, or the rate is 0.025, you have to divide by 0.025. Dividing by a fraction that is less than 1 will cause the quotient to be greater than the dividend, which is the answer is going to be greater than the number that you started off with. To address the problem of whether to multiply or divide, ratios may be used. While doing this, keep the quantities of the particular currency on one side of the ratio. Example, in an exchange between US and Jamaican, when writing the ratios, always keep US on the left-hand side. You may also choose the right-hand side as long as you are consistent. So if you remain consistent, you may use any side. But if you use US on one side, all the US must be on that same side all the time. And the Jamaican must be on the other side all the time. So let us see if we can use the ratio. So US dollars can be traded at the rate of US $1 to Jamaican 64. At the foregoing rate of exchange, what is the amount received in US for Jamaican $4,000? So what do? Write the exchange rate as a ratio with the US on the left-hand side. There you have it. The US is 1 to Jamaican 64. The first question is, what is the amount received in US? So the amount that we do not know is in US and the Jamaican is 40,000. So we're going to put the US on the left-hand side where it's always, which is the unknown, and then the 40,000 Jamaican is on the left. Now, we may also write the ratios as fractions, and we are going to equate those fractions. So one is 1 over 64, and the other is 8 over x over 40,000. Then we may solve. Of course, we are dividing by 40,000 here, so we multiply by 40,000 on the left-hand side. And then we put x on the left-hand side, and our answer is $625. US. The other part of the problem says, what is the amount received in Jamaican currency for US $562.50? Now, the rate can be written again. So write the exchange rate 1 to 60. Remember that the US part is here and the Jamaican, so it's 1 to 64, US to Jamaican. We need to find the Jamaican equivalent of US $562.50. Now we have the US, but we do not have the Jamaican. So what do we say? The US that we have stays on the US side, which is the left-hand side, and Y is the unknown amount. So the ratios may be written as fractions again, and they are equated. After they are equated, we are going to transpose in order to solve. So this y is going to be multiplied on this side, and the 64 that is divided here will multiply on that side, and we have $64,000, and that is in Jamaican currency. That is our problem. A Canadian tourist exchange Canadian 1,200 to Jamaican currency at a rate of Canadian $0.025, which turns out to be 2.5 cents to Jamaican $1, and let us see what happens. Write the exchange rate as a ratio, and we are going to say this is the Canadian part, is always on the left, the Jamaican is on the right. So if we are going to use the ratio, we have to write, what do we need to find first? The 1,200 is Canadian, so the 1,200 is on the Canadian side, and the one that we do not know is on the Jamaican side. Write the ratios as two fractions and equate them. And then we are going to do our little transposition. with the x being transposed up here and this being transposed down there. And our answer, after we have solved that, is 48,000 Jamaican dollars. So remember what we did? We took out 28,000 Jamaican and we are left with 20,000 Jamaican. That's what we have right there. So 20,000 Jamaican will be converted to Canadian currency using ratios again. So our amount is 20,000 Jamaican. That is our rate. Do not forget our rate. With the Canadian on the left side, the rate is what? 0.025 Canadian dollars to one Jamaican. So we have one Jamaican. Canadian, Jamaican. Now we have the Jamaican. So the $20,000 that we have is Jamaican is going to go on the Jamaican side. And what we do not know is why on the Canadian side. And of course, we are going to write as fractions and we are going to equate those fractions. After equating the fractions, what do we get? Transposing gives this as y. So y is equal to 0.025 times 20,000 and that gives $500 and that is Canadian currency. Now we are going to be using a table to solve our problem. Here is my favorite, the table. The name of the currencies are in the headers of the table. The exchange rate will be the next. The values in the rate will be placed under their respective header. When a value is to be calculated, it should be placed on the appropriate side of the table and its size relative to its counterpart should be consistent with the values in the table. So that's a mouthful, but let's see what that really means. We're going to be using the exchange rate. So we set up the table first. What do? We put in the headers. The US is over here and the Jamaican is over here. US here, Jamaican on this side. Now what is asked first? What is the first question that we have? So what is the amount received in US for Jamaican? $40,000. So $40,000 Jamaican will go right there, occupying the Jamaican side. Good. However, before we have this $40,000 Jamaican occupying the Jamaican side, the rate is placed inside of the table. So the rate is 1 US to Jamaican 64. Now, what is the significance of having the header and having this information here first? It means that when you look, you see that 1 is smaller than 64. Therefore, the amount that you're going to be placing on this side has to be smaller than the number that you have on this side. Smaller numbers, as dictated by the rate that we have inside the table, smaller numbers are placed on the left-hand side. So that we have what we had before. So by looking at the rate, the number on the US side is smaller. The associated value of the Jamaican, $40,000, must be a smaller number. To get this smaller number, we divide the 40,000 by 64. So of course, here we need to have a smaller number. And the rate is 1 to 64. Therefore, we need to divide here by 64. And this is our answer. No problem whatsoever. So we need to convert US $562.50 to Jamaican. So we put that on the US side. Now, any number here, the number must be smaller than the numbers that we have here. So we need to take this number and multiply by 64 in order that the number that we have on this side will be larger than the number that we have on this side, being consistent with what we have as the rate. So the rate tells us that any number that we have on this side must be larger than the one on this side. So we need to multiply by 64 on this side in order to get our answer. And that turns out to be $36,000. The values in the rate will tell us on which side the larger or smaller number should be. After making your calculations, the figures in the row of the table should match with the figures in the rate section. Large under large, small under small. So we are going to be working on the table again, and we are going to be using the Canadian currency this time against the Jamaican, and the rate is 0.025 to Jamaican $1. So set up the table. What do we put next? The currencies are placed in the header, Canadian on the left, Jamaican on the right. The value in the rate are placed in their respective columns. That's where we have that. Canadian is placed here, Jamaican there. And first, we are required to convert 1,200 Canadian to Jamaican. So the 1,200 is going to go on the Canadian side, like that. Now we are going to go to the Jamaican side. Now look at this number, a very small fraction in comparison to this. Therefore, the number that we are going to be using on this side has to be larger than the one that we are going to be having on this side. Now, how are we going to get a larger number by using 0.025? The only way we can get a larger number by using that rate, 0.025, is by dividing 1,200 by 0.025. By dividing by a fraction that is less than 1, the answer is greater than the number that we started off with, which is what we want. So we are going to divide by 0.025, and we have this statement right here. According to the relative sizes of the figures in the rate section, the number to be placed on the Jamaican side should be larger because 1 is greater than 0.025. To get a larger number, we need to divide by 0.025. And we are going to get 40,000. So we get 48,000 Jamaican. The figure is 0.025, which is a fraction that is less than 1. If we multiply a number by it, the answer will be smaller than the number that we started with. Conversely, if we divide by this, the answer will be larger than the dividend. I'm overemphasizing what we do with the 0.025 because most people have this strange notion that every time you want something larger, you multiply. Every time you want something smaller, you divide. It depends on the size of the number that you are dividing by. Dividing by a number that is less than 1, a fraction that is less than 1, will result in a larger number. That is, the answer is going to be larger than the number that we started off with, which is same as saying the quotient is larger than the dividend. So, of course, we are going to take out our 28 from the 48,000 and we are left with 20,000. That we are going to use. Use the 20,000 as the Jamaican to be converted to Canadian. Now we have this number on this side. If we are going to put a number on this side that is its counterpart, the number that we have on this side has to be smaller. So we have to multiply by 0.025 and we have $500. Multiplying does not always make your answer larger. It depends on the number that you are multiplying by. If you are multiplying by a fraction that is less than 1, like 0.025, your answer is going to be smaller than the number that you started off with. The long and short of the table is that all large numbers are on one side and all small numbers are on the other. If a calculation causes a larger number to be on the left when it should in fact be on the right, or it should be smaller, then the wrong arithmetic operation was used. Change multiplication to division or vice versa in order to maintain the consistency of the table. Using the table or ratios may not be necessary if you have no problem when you should multiply or divide. So if you can decide whether to multiply or divide without using a mathematical device, by all means go and multiply or divide without using any mathematical device, because mathematical devices make your work longer and takes much more time. When calculating without the use of ratios or table, if you do not spot the solution immediately, reason with yourself to determine whether the answer that you get should be a larger or smaller number than the one that you started with. So that is a way to figure out whether to multiply or divide. Say you are converting to Jamaican and is US 1 to Jamaican 64. When you convert to Jamaican, you should get a larger number in Jamaican currency than you are getting in the US currency. So you can use those rules of thumb in order to determine whether to multiply or divide. Now let us look at devaluation and re-evaluation. If it were not for this problem, exchange rate would probably not be considered worthy to be a part of Richard James Mathematics resources. Apart from the wrong approach to the solution of a problem by almost all of my students, everyday devaluation and revaluation of currencies has dictated that earthlings know how to adjust figures. The rate of exchange between two countries is $1.92 EC to US $1. There is a devaluation of the EC currency by 25% relative to the US component. What is the new rate of exchange? The table shows the exchange rate. US on the left, EC on the right. 1 to $1.92. EC devaluates by 25% or loses 25% of its value. Its new value is therefore 75%, and we may revisit or work with percentages, but may not be necessary. So it loses 25%, therefore its current value is 75% of what it valued before. Since devalue means to decrease, students interpret this to mean that the figure on the EC side will be smaller. They multiply $1.92 by 0.25 and make this the new rate. So they say that the new rate is $1 US to EC $1.44. Now this cannot possibly be right, because if the EC is devaluated, then it will take more to purchase the US. The number on the EC side gets smaller, but this is not a devaluation. If your currency becomes weaker, it takes more of yours to buy the others. This is not so from our calculation that we have there. Let us examine two different exchange rates between two currencies in different instances of time. 1989, 25 Jamaican to 1 US. 1995, 40 Jamaican to 1 US. So you see that we are taking more of the Jamaican to buy the US. Based on what we see Owen James doing all the time, using our everyday experience and simple logic, we will say that the Jamaican dollar has devaluated against its US counterpart from 1989 to 1995, because from 1989 to 1995 it takes more of the Jamaican to buy the US dollar. It is precisely because the Jamaican dollar decreased in value why it takes more to purchase the same quantity of US. If you are using pebbles of equal weight to balance the weight of a large rock, the lighter the pebbles, the greater the number of them that you will have to use. A devaluation of your currency does not cause a smaller quantity of it to purchase the same quantity of the counterpart. It takes more. So the rate of exchange between two currencies is the same problem. It is the same problem that we had before. There is a devaluation of EC currency of 25% relative to the US component. What is the new rate of exchange? If it was wrong to multiply $1.92 by 0.75, thereby getting a smaller number, then divide by 0.75 should be correct. Right. So we have divided by 0.75 and we get $2.56. Yes, that's a devaluation because it now takes more of the EC to purchase the US. We may solve the problem by treating the EC as if it can only now purchase 0.75 of the US. Therefore, multiplying the US side by 0.75. So that's another approach. So we can multiply this US side by 0.75. And now what we have, 75 cents to $1.92. So in order to return the rate to what it was before, not necessarily in value, but in the way that it was represented, $1 on the US side and others on the EC side. So the US side must always have $1. We are going to do that by dividing the 75 cents by 75 cents again. So divide this by this, we get 1, and we need to do it on the other side also. So in order that the figure on the US side may be equal to 1, divide both sides by 0.75. Right, and that is what we get for our answer. Now we have our correct answer. $1 US to EC $2.50. The rate of exchange between the countries is 48 Guyanese is equivalent to US $1. If the Guyanese currency were to be devaluated by 20%, what would have been the new rate of exchange? So the table shows the exchange rate. What do we say now? Guyanese devaluates by 20% or loses 20% of its value. The new value is therefore 80%. We will multiply or divide by 0.8, because that's what 80% is, 0.8. But how do we decide whether we multiply or divide by 0.8? Based on what we have examined so far, the number on the Guyanese side will increase. There's a devaluation of the Guyanese currency. It will take more of the Guyanese currency to purchase the EC. So this requires that we divide by 0.8. There's a fraction that we are going to be using as our rate. If we need a larger number, do we multiply or divide by 0.8? We divide by 0.8, because by dividing by 0.8, we are dividing by a number that is a fraction that is less than 1. And that will cause the quotient to be greater than the dividend. Right, so that is our new rate of exchange. This, of course, reflects a devaluation because it's now taking more of the Guyanese to purchase the EC. So when using a table, a devaluation of currency A necessitates an increase in the amount required to purchase B. Or, from a different perspective, A can now purchase less of B, and we decrease the number associated with B. The approach that we take is dependent on how the rate is given. The side that has $1 should always have $1. We should always work on the other side. So, any side that we have $1, keep $1 on that side. Work on the other side. And we know what a devaluation is. We know what a revaluation is. And we are going to do what it takes to ensure that what we have in our table reflects a devaluation or revaluation as is necessary or as is required. The rate of exchange between the countries, we have Jamaican $40 to Canadian $1. What will the new rate of exchange be if the Canadian currency experiences revaluation of 15% against its Jamaican counterpart? The table shows the exchange rates. Good. What are we going to do? We are going to maintain 1 on the Canadian side. Canadian revalues or increases value by 15%. Its new value is therefore 115%. We will multiply by, or we will divide by 1.15. The Canadian revalues. It will take more of the Jamaican to buy it. We therefore multiply the Jamaican side by 1.15. Remember that we do not interfere with the side that has $1 on it. Right. So it is the Canadian dollar that is increasing in value. If the Canadian dollar is increasing in value, it will take more of the Jamaican to purchase that, and that is what is reflected there. A revaluation of a currency A requires an increase in the figure that represents the currency B. The revaluation can also be demonstrated by decreasing the figure that represents the currency A also. The exchange rate between two countries, so we have that as Guyanese $1 to US 0.025. The US currency was devaluated by 25% against the Guyanese counterpart. What is the new rate of exchange? The table shows the exchange rate. That's it. And what is said? So the US is going to go down the value by 25%. Right, so it's going to devalue against the Guyanese. So what will happen? If the US devalues, it's going to take more to purchase. So if the US devalues, it's going to take more to purchase the Guyanese. So US devalued by 25%, its values therefore goes to 75% or 0.75. So what do we do with that 0.75? Since the US devaluated, it will take more of the US to purchase the Guyanese currency. Dividing by a fraction less than 1 gives a quotient that is greater than the dividend. We will therefore divide the figure on the US side by 0.75. So because the US experienced a devaluation, it is going to take more to purchase the Guyanese. How do we get more? If we are going to be using 0.75 as a rate, it is a fraction that is less than 1. We need to divide by 0.75. Now we have that table showing that it takes more of the US to purchase the Guyanese. Yes, it does, because the US lost some amount of value. The presentation of this topic will give you a headache if you refuse to think or to use your common sense. Just identify whether an increase or decrease in the figure is appropriate and make it happen like the Royal Bank of Scotland group. Some students do not know the difference between decrease to and decrease by. If a number goes down by 25%, we need to take off 25% of its value. So if it goes down by, we take off 25%. It is now worth 75%, and we multiply by 0.75. If it decreases to 25% of its value, its new value, or it is worth 25% now. So it's now worth 25% of its initial value, and we multiply by 0.25. That's the difference between decreases by and decreases to. If it decreases by, you take off that figure. If it decreases to, the figure that it moves, that is said that it decreases to, that is your new figure.